All right, people, lesson 2 for chapter 10. Let's see what we can get to here. 10.2 deals with finding arc measures. So still along the lines of circles. We're still talking about circles here, guys. So this section again, just like the first section, it's going to be there's a lot of terms involved. It's really kind of short. Not too many terms, but we'll talk about how to label things, how to write different notations, things like that. So let's get rolling with this. First of all, the first thing we need to define, and again, I don't know if I'll have guided notes for you guys. We'll see. I don't have them made up yet, but I'll see if I can get to them. But if we don't have guided notes, we might need to pause a little bit more. But here we go. So we've got a central angle. That's the first thing. So a central angle is an angle whose vertex is the center of the circle. That's all there is to it. So if you have an angle, the vertex, remember, is the end point of the two rays that make up the angle. So it's an angle whose vertex is the center of the circle. So here we go. Here's a picture of it. I'll just keep scrolling down here. So that is an example of a central angle. All right. So let's say C is the center of this circle. We've got, what's going to happen is it's going to divide it into two arcs. All right. So if we have this central angle, whatever this angle is, I don't really know. It doesn't really matter what that angle is for right now, for our purposes. But yeah, that'll be the angle. And it splits it into two arcs, like I was saying. It splits it into a major arc and a minor arc. All right. So watch what's happening here. So this angle is intercepting. Well, it's going to intercept this small arc from A to B. Okay, so let me draw this out. I'll draw this in green. From there to there. That's going to be the minor arc. Okay, when you think major and minor, obviously major is going to be bigger than minor. All right, so that's an easy way to remember this. So that right there, the one in green, is the minor arc. Now, like I said, it divides it into a major arc as well. So that we can look at from A to B there. We could also go around the circle the other direction. Okay? So if we went around the circle the other direction, that's another arc that we have to deal with. Okay? And by the way, I didn't define this. I didn't write this down. But hopefully you guys know that an arc is just part of a circle. That's all an arc is. Right. So the actual circle itself is this piece that I'm highlighting, or that I'm talking about with my hand here. That's the actual circle. Again, this is inside the circle, this is outside the circle. But the actual circle itself is right there. And so it's just part of a circle. So guys, this arc is a part of a circle, right? And so is the major arc. So let me write this out. This is the major arc, the one in blue. Okay. So that's pretty much all there is to it. Now, the definition, I haven't talked about the definition. I've kind of explained what it is. But the definition of a minor arc is it's going to be an arc that is less than 180 degrees. Should be pretty straightforward. And we haven't, let me mention this now. You guys should know, I think from previous experience, that a circle has how many degrees? And the answer is 360. There's 360 degrees in a circle. So it's less than half the circle. Okay? So it's less than 180 degrees. That's what a minor arc is. Hopefully that makes sense. And a major arc, you guys might be able to guess what a major arc is going to be. It's an arc that is greater than 180 degrees. There we go. All right, so we've talked about those two things. Now, we haven't talked about an arc that is equal to 180 degrees. So think about that. What would we call an arc that's equal to 180 degrees? That's exactly half a circle. What do we call something that is half a circle? That's a hint, half. It's a semicircle. All right, it's going to be a semicircle. So guys, a semicircle is equal to 180 degrees. So there's three different arcs you could have. You have major arc, minor arc, and a semicircle. All right, so that's the idea. Now we're also going to talk about how to label this. So let's see if we can label a minor arc, a major arc, and we'll talk about semicircle as well. So how to label this is Minor arcs, you always write them with 2 letters. So that's how, if the book just tells you, or if you're just told that you have arc AB, you automatically now know that it's a minor arc because they only wrote it with 2 letters. All right, so you can determine that, so like for example, let me go back up here. So I'll scroll down in a second. But when I go back up here, if I say find the measure of arc AB, which we'll talk about the measure of it in a second, but if I said find the measure of arc AB, you wouldn't really know which one to find if you didn't know that fact that minor arcs are written with 2 letters. So let me explain. So if I said find the measure of arc AB, well, you might think AB is this arc, or you might think AB is this mark. Okay? Sorry, I meant to say arc. Okay, no, not mark. So again, if we didn't know that fact, then you might be confused as to which arc we're talking about. So that's why we write minor arcs with 2 letters. So now I know for sure that that's the arc we're talking about, AB, just from there to there. Okay. So with that being said, let's keep going. Now major arc, you might be able to guess how we write major arcs. How many letters? Kind of gave it away. 3. All right, so there's going to be 3 letters you need to use when you're labeling a major arc. So major arcs, and notice I put up here, I ran out of room. I forgot about it until I added it later. Major arcs and semicircles are written with 3 letters. So an example that I have is arc ADB, or you could write it as arc BDA. So I'm talking about the circle that I've drawn up there previously. So I'll scroll back up to that. So let's go ahead and do that. Let me scroll back up. So this arc right here, ADB, we need to write it with 3 letters. So there's one point here that I have to know. I have to label a point out here if I want to refer to the arc from A to D to B. Hopefully that makes sense why we need 3. All right, so with a minor arc we need 2. With a major arc we need 3. We need a reference point. So this point tells us which direction we're going. So we're going from A to D to B, or you could write it as from B to D to A. Just like with the minor arc, you could have written it as AB, arc AB, or arc BA. And I didn't mention this, but I have it written down. The arc symbol is that. Okay, I'll just draw a little arch. So there we go. Next thing, this is kind of I guess it's kind of a big fact, big asterisk here, big star. Let me just scroll all the way down here. Let's keep going. All right, there we go. So arc measures are determined by their central angles. I'm going to use the term intercepted a lot. The intercepted arcs is what we're talking about here. So the measure of the central angle is going to equal the measure of the intercepted arc. So we're talking about the arc that's formed on the inside of the central angle, all right, in between the central angle. So for example, let me give you an example here. Here we go. What if I said that was, I'm just going to make up a number here, guys. What if I said this is 40 degrees? Okay. If that central angle is 40 degrees, then the measure of arc AB is going to equal 40 degrees. Okay? That's all there is to it. So if you've got the measure of the central angle, you have the measure of its intercepted arc. And arc AB is going to be the intercepted arc, the arc on the inside of there. Okay? So that is how you figure out the measure of an arc. So another thing I want to mention while we're at it, so if I found that this is 40 degrees, and let me move this over so I don't have to worry about that. That is my minor arc there. This would be 40 degrees. A lot of times we just write the degree measure of the arc outside it. So guys, again, we talked about I mentioned how many degrees are in a circle. Answer is 360. So if there's 360 degrees in this entire circle, if we have 40 of them with this minor arc, I want you to think, how can we find the measure of that major arc from A to D to B? And hopefully you got that. You just take 360 minus 40. So the measure of arc ADB is going to be, 360 minus 40 is 320. Okay. So this whole arc right there would be 320 degrees. Hopefully that makes sense. I was about to say any questions. I caught myself. All right, so here we go. Let's keep going. Next thing. Let's try this problem right here. So using those facts that we just talked about, we're going to find the measure of each arc of circle P. And it tells us, this is important, this is an important fact, RT is a diameter. So whether I have guided notes or you're writing this down on your own, again, probably want to pause it. Now there's actually three things we want to find here. So I'll scroll down. We want to find arc RS, which we will. We'll find arc RTS, and we'll also figure out what RST is. See, and I want you to notice there's a difference between arc RTS and arc RST. Okay, we'll talk about that. Okay, so here goes. RS, that one's really easy. Okay, if you use the fact that I just wrote down, that we just talked about, we've got the central angle here from R to P to S. We've got that central angle. So if we know that central angle, what is the measure? And by the way, that's its intercepted arc. What is going to be the measure of that arc? If you said 110 degrees, we have a winner. 110 degrees. All right, so again, the measure of the central angle has to equal the measure of its intercepted arc. There we go. We'll write this down here. Part A done. That was easy. All right, part B is a little bit different. So let me highlight this in a different color. So RTS. So you guys start with R, go around to T, and then go to S. So that right there is basically what's left over of the entire circle. So if we know one of this arc from R to S, the one in green, if that's 110, again, just like we've already talked about, the way we can find the major arc there is, there's 360 degrees in a circle. That doesn't change. And take 360 minus what we already have. So what is 360 minus 110? And the answer is, I'm just doing it in my head, 250, I think. So that'd be 250 degrees. All right. Like I said, we got one more. Let's go down to the last one. RST. Now, believe it or not, this one is, if you read the question, if you know what it's asking, if you read that information, then this one should be easy as well, because RST, let me highlight that in blue this time. So RST is from here to there to there. Well, the way we can figure that out is the information right here. It says RT is a diameter. So hopefully this makes good sense that if you have a diameter, it's going to split the circle into two semicircles. So the length not the length, but the measure from here to here, from R to T this way, and is going to be the same as the measure from here to here, R to S to T. So if those measures are the same, if they're equal, 360 divided by 2, that's a semicircle, guys. Diameters always divide the circle into two semicircles. So we just talked about what the measure of a semicircle is. It's 180 degrees. So the answer here is 180 degrees. Okay. Moving on. This is really the last fact that in this section. This section is kind of short. So let's go and write this down. Again, might be in your guided notes here. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So really, guys, we've used this. I'll kind of go back to that last example to explain. But another way to explain this is to draw the picture and write this fact down. So pause it if you need to. I'm going to scroll down here now. All right. So what we're saying here, let me highlight this in different colors. So the measure of arc ABC, so let's find ABC, I'll do this one in blue. A to B to C, that arc right there. That's going to equal the measure of arc AB plus the measure of arc BC. And that should make sense. This is very similar. We talked at the beginning of geometry. We talked about the segment addition postulate, and we also talked about the angle addition postulate. Just basically, this is similar to that. We're saying that if we have adjacent arcs here, we're allowed to add those together, and it gives us the bigger arc. Okay, so that's all there is to it. So don't overthink this one. It's really not that bad. Now, when we say adjacent arcs, there can't be any overlap. All right, so this is important to point out. There cannot be any overlap. So what I mean by that is, let's say I had another point here, point D. I cannot say that arc AD plus, let me do this one in, how about red, plus arc BC. I can't say that those two add to equal this same arc. I can't say that they add to equal arc ABC. All right, so because they overlap here, we've got the piece of arc that we're going to be counting twice. All right, so that's why those arcs will not be true. So adjacent arcs, they have to be where one of the arcs ends, the other one has to begin. All right, so these are adjacent arcs, AB and BC. There cannot be any overlap. All right, here we go. So let me go back. I think, let me see what, that's just a different, more facts. Let me go back here. So if you would have found this, I didn't ask you to do this, but if we wanted to find arc ST right here, there's a couple different ways you could do it, but you could just take 180, which we found that semicircle to be, and subtract it from, or take 180 minus 110, so that should be 70 degrees, and so should its central angle. Okay. So those are both going to be 70 degrees. So what we're saying here is that we can take ST plus RS, and that's got to equal the entire semicircle. So 70 plus 110 is in fact 180. All right, so that's what the arc, just to apply the arc addition postulate. That's what that would look like. Okay? So hopefully that made sense. And here we go. So the last thing, the last fact, two facts actually, that we want to write down, are these two. So go ahead and do that. Again, pause it if you need to. But congruent circles are circles with the same radius. Congruent arcs are arcs that have the same measure. And they are arcs of the same circle or congruent circles. So I'm just going to draw some examples of these, and then we'll call it a day. We'll call it a lesson here. All right, here we go. So, first of all, congruent circles. Sorry, don't write this down yet. Let me think this through. Let me draw something else. Let's talk about congruent circles real quick. So here we go. We got a circle there. What I'm going to do, I'm just going to copy and paste this, guys, just to show you that, I haven't changed it at all. Copy, paste. All right, so those are going to be congruent circles. The reason they're congruent circles, like I said, I didn't change the size, but we can always tell how big a circle is by the radius. Okay, so I don't know if that's R. We haven't changed this at all, so this is still R. So if R is 5 here, R is going to be 5 here. Those have to be congruent circles. Those are going to be the same exact size. Remember, congruency means same shape and same size. Well, obviously, all circles are going to be the same shape. I mean, circles are circles. But yeah, you can make them bigger or smaller. If you change the radius, it's going to make it bigger. All right, so that's the idea. Or, my bad. If you change the radius, it's going to make it bigger or smaller. I can make the radius smaller as well. All right, so that's just a picture of congruent circles. Now I want to kind of talk about congruent arcs now. It's important here to mention this because we said congruent arcs are arcs that have the same measure, and they are arcs of the same circle or congruent circles. So if you look over here, what I did here, I kept the same measure, but what I did was I made this circle right here. Hopefully you can tell on the camera. It's a little bit bigger than this guy. So I made the circle a little bit bigger. So this arc length is actually going to be a little bit longer than that arc length. So therefore, these are not congruent arcs. Okay? So let me make sure I'm clear on that. So this arc right here, I know their measures are equal, but the arcs themselves are not congruent because this guy's arc length is going to be longer than this guy's arc length. All right? So that's why the definition applies here. If we go back to it, the same measure which those two did, but they were not congruent because they weren't of the same circle or congruent circles. Okay? So hopefully that's clear. That's about all this section deals with. So just a lot more terminology, and also knowing how to label these things is important as well. So you guys need to know how to do that. So to review a little bit, let me just go back real quick. You need to know what a central angle is, minor arc, major arc, semicircle as well. You need to know how to label those. Okay, 2 letters with minor arcs, 3 letters with major arcs, and semicircles as well. Okay, semicircles still need 3 letters. And this is important, guys. Don't forget this. Arc measures are determined by their central angles. All right, so we're going to be able to figure out a lot of different arc measures as long as you know the central angle. They're going to be the same. All right, so the central angle is going to be the same. Okay, and then we did an example. You also need to know the arc addition postulate. This one's basically just saying you can add arcs together as long as they don't overlap. And those 2 facts, those 2 terms, congruent circles, congruent arcs. You need to know what those are. All right, that'll do it for this lesson. Thanks.